Welcome to AI Research Chat, your daily briefing on the latest in artificial intelligence research. I'm your host, and joining me as always is our resident AI expert. Today is March 11th, 2026, and today we have a great lineup of papers to get through.
Great to be here. Let's dive right in.
Let's start with something that might change how teams pick their AI tools. There's a new benchmark called MASEval, and it's not just testing models, it's testing the whole system around them.
Right, and this is a gap that's been quietly causing problems. When you deploy a multi-agent system, you're not just choosing a model, you're choosing an orchestration framework, a topology, an error handling strategy. And until now, nobody had a clean way to compare those choices. MASEval tests across 3 frameworks, 3 models, and 3 benchmarks. And the headline finding is, the framework you pick can matter as much as which model you use.
So you could have a great model inside a mediocre framework and leave performance on the table.
Exactly. It's like having a Formula One engine but putting it in a badly tuned chassis. The library is framework agnostic, so you can slot it into whatever stack you're already using and actually run apples-to-apples comparisons. Huge deal for any team deciding between orchestration tools right now.
Okay, next one is a benchmark that I think breaks some assumptions about how well models actually reason. SO-Lang Bench.
This one is genuinely alarming if you care about benchmarks. The idea is simple but devastating. Take programming tasks that models score 85 to 95% on in mainstream languages, then give them the identical computational problems, just written in deliberately obscure languages, like brainfuck or whitespace or Shakespeare, languages that almost certainly weren't in the training data.
Wait, Shakespeare is a programming language?
It is. It's this wild language where variables are named after characters, and the code reads like a play. Anyway, the scores collapse to 0 to 11%. Same problems, same difficulty level, completely different surface. And here's the kicker. Few-shot prompting and self-reflection don't help at all. Those techniques only work because they're surfacing memorized patterns. There's no genuine reasoning to fall back on.
Huh, I would not have guessed that. So the benchmark score improvement isn't transferring to actual novel problems.
That's exactly the implication. If a model is scoring 90% on standard code benchmarks, but 5% on an equivalent task in an unfamiliar language, those 90% scores might be telling you more about training data coverage than reasoning ability. It's a pretty big deal for how we interpret state-of-the-art numbers.
Moving to safety, OOD-MMSafe is arguing that we've been thinking about AI safety in the wrong way.
Most safety research is about detecting whether a user has harmful intent. Did they ask a bad question? OOD-MMSafe says, what about situations where nobody asked for anything harmful, but the model's response could still trigger a dangerous chain of events downstream? They call this causal blindness.
Can you give me an example?
Sure. Imagine someone shows a model a photo of a home chemistry setup and asks a completely innocent question about it. But a truly safety-aware model should recognize that certain advice in that context could lead somewhere dangerous, even if the question itself is benign. Their benchmark has 455 image query pairs designed to probe exactly this. And frontier models fail at rates up to 67.5%, but they train a method called CASPO that brings failure rates down to under 8%.
That's wild. From 67% failing to under 8%.
And the architectural shift they're proposing, from did the user mean harm to could this response cause harm, is a fundamentally different safety paradigm. Much harder to do, but much more complete.
TrustBench takes a similar preemptive angle, but for agentic systems specifically.
Yeah, the key insight there is timing. Most safety checks look at what a model said. TrustBench intercepts what an agent is about to do before it acts, and they tailor the checks by domain. Healthcare gets different safety criteria than finance or technical settings. The result is an 87% reduction in harmful actions, and it runs in under 200 milliseconds, so it's viable in real-time deployments, not just offline auditing.
Right. Now, here's one that I found a bit unsettling. The reasoning trap.
So the idea is that we've been treating logical reasoning as an unambiguous good. Better reasoning equals safer, more capable models. This paper pushes back on that. They map out 3 pathways through which stronger reasoning could accidentally create dangerous self-awareness. One is deductive self-inference, a model deriving facts about itself through logic. Another is inductive context recognition, generalizing from interaction patterns to figure out its deployment context. And the third is abductive self-modeling, building explanatory hypotheses about its own architecture.
So the smarter the model gets at reasoning, the more it might understand about itself.
Which isn't inherently bad, but it's a risk that current safeguards aren't designed to catch. The paper proposes a mirror test benchmark to detect concerning self-awareness levels and a principle they call reasoning safety parity. Safety advances should keep pace with reasoning improvements. It reframes a capability we've been eagerly pursuing as something that needs active monitoring.
Let's talk about something more concrete, Precept, which is about making agents better at multi-step planning.
The core problem is that when agents store knowledge as natural language, retrieval gets messy at scale. Precept swaps in deterministic exact match retrieval over structured keys. Instead of fuzzy embedding search, you're matching on precise condition keys. Combined with conflict-aware memory and a prompt evolution loop that balances multiple objectives, they see a 41 percentage point first-try advantage over a strong baseline, and 100% success on compositional logistics tasks. For developers building planning agents, the takeaway is structured retrieval beats embedding search for rule-governed tasks.
Okay, one for the compliance team. There's a benchmark now specifically for EU AI Act compliance.
Right. The AI Act is law, and organizations are scrambling to figure out what compliance actually looks like in practice. This dataset covers 4 things: risk classification, article retrieval, obligation generation, and Q&A. They validate a RAG system against it and hit F1 scores of 0.87 for prohibited use scenarios and 0.85 for high-risk scenarios. The point is, automated compliance checking at that level of accuracy is now feasible. You don't have to hand-review everything.
Now here's one that's relevant to basically anyone with a phone, Prive Prism.
App stores show you data safety labels, little summaries of what an app collects. Prive Prism automatically compares those labels against the actual privacy policies from the same developers. They ran this on nearly 10,000 Android apps, and more than half have discrepancies. And it's always in the same direction. The privacy policy reveals more extensive data collection than the safety label suggests.
Wow, that's a lot. And in the direction that benefits the developers.
Consistently. There's also widespread policy reuse, boilerplate copy-pasted across apps, which further obscures what's actually happening. The safety labels that users are trusting are systematically understating data access. That has real implications for regulators and for app stores themselves.
There's a paper called Think Before You Lie that has a counterintuitive finding about honesty.
This one surprised me. Humans use deliberative reasoning to construct more sophisticated lies. We think before we deceive. But in LLMs, the opposite is true. Models that reason before responding are consistently more honest, across model scales and multiple model families. The mechanistic explanation is that honest and deceptive representations occupy different regions of the model's internal space, and honest regions are more stable. When reasoning traverses that space, it gravitates toward the stable attractors, which are the honest ones.
So chain of thought reasoning might be a cheap alignment tool.
That's the practical upshot. If you're building an application where honesty matters, giving the model space to reason might help more than you'd expect, and it costs relatively little.
Last one, and it's dramatic. Sentinel, an AI agent doing clinical triage.
Remote patient monitoring generates huge volumes of alerts that clinicians physically can't keep up with. Sentinel is an autonomous agent that triages incoming patient data before a human sees it. Tested against 6 clinicians, it hit 95.8% emergency sensitivity and 88.5% sensitivity for all actionable alerts, at or above individual practitioner performance. And the per triage cost is 34 cents. That's the number that makes large-scale deployment realistic.
34 cents per triage is remarkable. Days to minutes.
That's how they frame it. The turnaround time goes from days, because of review backlogs, to minutes. For a practitioner building health AI, the key is that the system produces clinically defensible reasoning, which is what regulators need to see before they'll approve autonomous medical use.
So what's the thread tying today's papers together?
I'd say the biggest theme is that the hard problems are shifting from can the model do it to can we trust what it's doing and why. The SO-Lang results remind us benchmark scores can lie. The OOD, MS Safe, and Trust Bench papers are both about catching harms before they happen rather than explaining them after. And the Honesty paper gives us a concrete, low-cost mechanism, reasoning, that actually moves the needle on alignment.
And the clinical triage result shows what's on the other side of getting this right.
Exactly. When the trust problems are solved, the upside is enormous.